up to this point, we've dealt with perfect squares. And we've figured out that the square root of 25 is 5, or the square root of 36 is 6. Notice I'm just giving the positive because I didn't put a sign there. The roots, if I asked for it that way, of 25 would be plus or minus 5. Okay? So if they ask for it this way, you can simply answer positive. If they ask for it this way, they're asking for the negative version. And if they just say, give me the roots, you're going to give both. Okay? But not all numbers are perfect squares. Not all numbers are perfect squares. What you're going to learn about today is how to work with various numbers that may or may not be perfect squares, or maybe a combination of both. And we're going to kick it off with example 1, where we encounter a square root of 180. Notice there's no sign here, so they're simply asking for the square root of 180. If you plug it into your calculator, I'm not sure what yours will say. Holy cow. I'm going to give that back. Square root of 180. You're going to get something like this. Okay? More than likely, you'll get something like this. But when they say simplify, they do not mean solve. It's not the exact same thing. They want you to write this in the simplest terms without being exact. Does that make sense? It's not the same as estimate, but you're writing it in the simplest form. Now, in order to solve this, or to simplify this, you need to identify any perfect square factors of 180. Okay? Step 1, identify any perfect square factors of the number under the radical. Happens to be 180. 180 is a factor of 36 and 5. I'm sorry, yes. Therefore, 36 times 5 is 180. Well, then the square root of 36 times the square root of 5 is the square root of 180. You see how I'm tracking this? 36 is the perfect square, right? The square root of which is a 6. 5 is not. So the answer is 6 times the square root of 5, which you would simply write 6 radical 5. The number preceding the radical is multiplying by the number within the radical. Okay? This is all you need when you are asked to simplify. Okay? Step 2 was root it. Okay? These don't get terribly hard, I don't think. For the most part, you should be able to figure out the factors that would work for you. You know you are done if no other perfect squares can be factored out of the number under the radical. Okay, I know I'm done because 5's only factors are 1 and 5. The square root of 1 is 1. 1 times 6 is still 6. It doesn't change anything. That's how I know I'm done. Okay? In contrast, I want to show you this one. Let's just say the square root of 64. Don't answer this. Hang on a minute. I'm making this up, so let me make sure. Okay. Let's just say I forget that this is a perfect square, and I identify this as being 16 and 4. Okay? And I forget that 4 is a perfect square, and I say The square root of this is 4. Therefore, the answer must be 4 times radical 4. Have I simplified this enough?
No.
This one's obvious and easy. No, of course not. This is also a perfect square, which then becomes a 2. That 2 gets multiplied by the 4, and obviously your answer is 8. If you root it out completely, whatever's left under the radical cannot be factored into a factor including a perfect square. And we'll practice this more. Okay? Here's an example like number 1. Radical 63. Unlike radical 64, this isn't a perfect square. This is actually checkpoint 1. Give me some factors of 63, one of whom is a perfect square. Factors of 63, one of whom is a perfect square. 9 and 7 is right. So it is 9 times 7. Okay, oftentimes I'll just write it like this instead of writing it like that. Same idea. 9 is a perfect square whose square root is a 3. What you are left with is 3 radical 7. The 9 has a root of 3, therefore the 3 came out. It doesn't get any tougher even when you're dealing with letters. Here's example 2. Radical 24s squared. Perfect square factors of 24, 6 and 4, right? Because there's a 4. And s squared is a perfect square, isn't it? Awesome. Square root of 4 is 2. Square root of s squared is s. You are left with a 6 under the radical. Square root of 4 comes out. Square root of s squared comes out. All that's left under the radical is the 6. There's your final answer. Okay? Even in division, all of these same rules hold. This is example 3. In division, the same exact rules hold. Example 3, they give you radical 13 over 36. First thing I want to encourage you to do, break it into the square root over the square root. If you don't do that, it'll look a little tricky. Okay? The reason you have to do this is because only one of these is a perfect square. Okay? If both of them were a perfect square, it's slightly different, and I'll show you that. 13 does not have any perfect square factors. The square root of 36 is 6. Okay? If you have a scenario where the fraction has both terms that are a perfect square, your answer is going to be 2/8. Okay, square root of 4 is 2, square root of 64 is 8. Both of those items popped out of the radical. If you left it like this, you would still end up with the same answer. Yeah, then you'd reduce it, of course. Always reduce. When in doubt, reduce. You'll never get in trouble for reducing unless you're told, do not reduce. Okay? Checkpoint, just a couple more items, and then I'm going to let you go. How are you guys doing so far? We're going to practice a little more. Huh?
Honestly, not so good.
Not so good. Okay, let's practice then. Cool? We'll practice some. Checkpoint 2. Thank you for being honest with me. Hold on. 54. Here's a letter example. If you remember step 1, I told you guys to identify square root factors. Factors of 54. Anybody know of one that has a perfect square in it?
9.
9 times 6. Okay. I rewrite it with the factors.
Don't pass to the office, please.
And I keep them separate like that. You probably can already see that the 9 is a perfect square and the t squared is a perfect square. The 6 is not a perfect square and it has no factors that are a perfect square. 1 and 6, 3 and 2. Okay? Square root of 9, 3. Square root of t squared, t. Those two items come out of the radical. What is left underneath stays within. Okay? That's an example using a mixture of numbers and letters. How about this one? I'm going to do one more of this and I'm going to keep going with some more examples. This one. This one is purely numeric. And it's not easy. I don't know. So you want to know what I do? Is I just start dividing. And look for a perfect square. 98 divided by 2. Oh, boom, look at that. 2 and 49 are factors of 98 and do include a perfect square. Okay? Break those apart. Square root of 49 is 7. It comes out of the radical. The 2 stays underneath because there's nothing I can pull out of the 2. The 2 is not a perfect square. Okay? Another fractional sample, checkpoint 3. Radical 15 over 16. Do you guys remember how I said if one of them is a perfect square and the other one isn't, you definitely want to break it? So we're going to break it apart. Look for perfect square factors or tell me if it's a perfect square. Well,
16.
Bravo. Square root of 16 is 4. Factors of 15, 1 and 15, 3 and 5. Any of those perfect squares? You're stuck with it then. This is your answer. Is that helping a little bit? Okay, practice, practice, I know. All right, checkpoint 4. 32 n squared. Ah, that's a 6. N squared. Break it up. Radical 32, because radical 32 is not a perfect square. N squared is, though, isn't it? Anybody know what the square root of n squared is? Good. Let me ask you that. Well, you know what? Let me finish that. Finish this. Perfect square factors of 32. 2 and 16. Right away I went 8 and 4. No good. Because there's another 4 in that 8. Okay? So if you did this, 8 and 4, okay, and you pulled that 2 out, 2 radical 8, I would circle this and say simplify. Why? Because the 2 radical 8 is actually 4 times 2 underneath there, because 4 times 2 is 8 and 4 is a perfect square. Okay? That 4 would come out as a 2 and get multiplied by the 2 you started with, leaving you with 4 radical 2 over n. That's why it's important to find the largest perfect square factor, which of 32 was 16 and 2. Okay? Then we would go on from here to here to here. Okay? The largest perfect square factor is 32 is 16. Using these expressions, you're going to solve stuff like in example 4. After a car's accident, a police officer measures the length of the skid marks. You know how length times width gives you area? It's a formula for area, right? Well, the formula, the square root of 27L radical 27L, gives the car's speed in miles per hour upon hitting the brakes. Kind of handy for the police officers, no? I'm going to go into law enforcement. I don't need to know math. Yeah, you do. So the police officer takes out his measuring tape and he measures this item, or the length of the skid marks. By the way, let's simplify this, okay? 9 times 3 times L. Is there a perfect square in that mess? I kind of did it on purpose. 3L. Okay? This is the simplified version of this. The police officer measures that it's 125 feet long. Let's approximate the car's speed. Based on this, we plug in the car's length at L. Okay, do you guys see how I replaced L with 125, because that's the amount of feet? 125 times 3 is 375, right? 3 radical 375. Factors of that, or is it a perfect square? Radical 375. Let's hope. Nope, not so much. Approximate using a calculator. So, I just came up with that as the square root of 375. We're approximating, so it's okay to use this decimal value. I have to multiply the approximate value of the square root of 375 by the 3 that precedes it, which gave me that. This car was going approximately 58 miles per hour when he hit the brakes. Question C in example 4. If he was driving in a 20 mile per hour zone, would he receive a ticket?
Yes.
Yeah. Why do you think you need math in law enforcement? There's a lot of reasons.